Okay, let's start with our next problem. Next problem is based on beta function. Next problem is 0 to infinity x to the power 8 multiplied by 1 minus x to the power 6 divided by 1 plus x to the power 24 dx, and I need to show that this is equal to 0. Okay, the only property having limits 0 to infinity, the property is beta of mn, this is equal to 0 to infinity x to the power m minus 1 divided by 1 plus x to the power m plus n dx, right? So the given problem, left hand side of this problem, we will try to express in this form. Okay, so let's start with the left hand side, that is 0 to infinity x to the power 8 1 minus x to the power 6 divided by 1 plus x to the power 24 dx. Okay, let's start with simplifying. Just multiply inside by x to the power 8. So x to the power 8 minus x to the power 8 into 16, 6, so that is 14. So divided by 1 plus x to the power 24 dx. This is same as 0 to infinity. I'll just separate this numerator. So this is x to the power 8 divided by 1 plus x raised to 24 minus 0 to infinity x to the power 14 divided by 1 plus x to the power 24, right? Now I can write down this 24 as 9 plus 15. Why I am writing this? Because let's see if I express this 24 as 9 plus 15, and if I choose m is equal to 9, so in numerator I am having x to the power m minus 1, which is 8. So this is the good thing. Then again in the second part also I'll express 1 plus x to the power 24 as, let's write down in the reverse order, that is 15 plus 9. So 15 minus 1, so 14. In numerator already I am having x to the power 14. So if I try to compare both parts with this definition, so what we are having here, this is nothing but beta of m comma n is this. If I compare this with this, what is the value of m? 9, and value of n is 15. So this is minus beta of, here value of m is 15 and n is 9. And earlier we have shown that beta is symmetric, so beta of m comma n is same as beta of n comma m. So these two are same, so that means this must be equal to 0. Okay, the only thing we are using this property to solve the whole problem. Okay, then the next problem again we are going to take based on this property only. The next problem is show that integral from 0 to infinity x to the power m minus 1 divided by a plus b x raised to m plus n dx, this is equal to a raised to n into b raised to m into beta of m comma n. So again I am going to use the same property. Why? In numerator I am having x to the power m minus 1, but instead of 1 plus x I am having a plus bx in the denominator. So we will try to express this in the form of 1 plus bx, 1 plus x. So let's start with the left hand side. So this is x to the power m minus 1 divided by a plus bx raised to m plus n dx. If I am taking a common from denominator, what we have, this is a I am taking common, and so that this is 1 plus b by ax raised to m plus n, right? So this is nothing but a raised to m plus n. So this is a constant, take it outside, and this is 0 to infinity x to the power m minus 1 divided by 1 plus b by a raised to x and into x raised to m plus n, right? Now if I compare this with that property, in that case I am having only x here, so let's start with substituting b by a times x is equal to t. So what is dx? Dx is nothing but, here a by b is just a constant, a by b into dt, right? And let's see what are the limits. Limits will remain same as it is, because I'm just taking multiple of x is equal to t. So x and t, this is from 0 to infinity.